Hello, welcome. Thanks so much for joining us this afternoon. We're going to give everyone just a few seconds to settle in, and then we'll jump right in and get started. This is Sphero's webinar on AI literacy, how Sphero teaches AI literacy through hands-on learning. And thank you all so much for joining us. Um, Couple housekeeping items. Is sometimes that chat likes to default to sending messages to the panelists. So make sure you check out that chat feature and make sure it says send chat to everyone. And once you've done that, it would be great if you could say hi, tell us where you're from and what you teach. Um, so happy to have you here joining us. This webinar also has a, oh, great. There we go. Hi, Sarah from Illinois. Hi, Michelle. Hi, Stephen. Thank you. Hi, Faye. It's good to see everyone here. Oh my gosh, now I'm behind. Excellent. I see people still filtering into the room as well. So again, you're here joining us for Sphero's AI literacy webinar on how to use our tools to contribute to AI education in your classroom. It looks like everyone's figured out the chat. I'll move on to the second feature here. Please use the Q&A feature in the webinar to ask questions. We have a team of moderators behind the scenes that will be answering questions as they come in, as well as pinging us when there's a question they want us to address live. This webinar will be about 35 minutes. We'll be sure to save some time for Q&A at the end. And be patient. This webinar is being recorded, so give us a couple of days after the fact, and we'll send you an email with the recording to the webinar along with the PD certificate. Quick introductions. My name is Todd Johnston. I'm the Director of Education Content at Sphero. I've been with Sphero for almost 5 years. So that means I really spend my days creating and curating lessons and resources that students and teachers use in the classroom to get the most out of our products. Today is a special webinar though, because we have two folks here that don't often participate in these webinars. And these two people work behind the scenes on a lot of our software solutions, making our websites and our programming apps as great as they are. So I'll give them a second to introduce themselves.
Hi, everyone. I'm Micah. I've been at Sphero for 8 years and I am a software product manager. So I primarily am responsible for managing software efforts, releasing new versions of our apps, and working on different features, designs, QA, things like that.
And I'm Brian. I've been at Sphero for 7 years, and I'm responsible for the software we develop and also the software we use to run the business and also data privacy issues.
Great, thank you both. Quick overview of our agenda. First, we're going to talk about Sphero's vision for AI education. Then we're going to dive into some details about Sphero's AI Assistant, which is a new feature in our apps that allows students and teachers to leverage some AI. We're going to preview or talk about a feature we're planning and working on that goes around collecting data from our robots and then using that data to train machine learning models. And then we're going to review some lessons that Sphero has contributed to the Hour of AI catalog. And last but not least, we'll save time for that Q&A at the end. Before we get into it, though, we wanted to start with a quick poll. So on a scale of 1 to 5, 1 being not at all and 5 being very, how comfortable are you teaching about AI concepts and AI literacy? Great. I'm seeing a lot of results flying in here. And the results, can I share these results? Oh, it looks like I'm going to hit share results and they're being shared right now. So this is great because we have the full spectrum here. We have some people that are more confident and some people that are less confident. To be frank, Myself as a curriculum developer, this is all very new to us too, right? So there's times when I'm still getting up to speed on what AI is and how it should be incorporated into the classroom. So we are all on a steep learning curve. We're going to move on to the next section where we're going to talk about Sphero's vision for AI education.
So when we set out to create our AI capabilities, safety was our clear top priority. And we follow 4 principles as we try to make sure everything we do is the safest possible implementation. So first things first, we don't put any personally identifiable data into AI. Second, we don't allow students to enter free text. So if you were to go to a chat GPT or something similar, you would have a big text box and you could type in anything you want, which means that the output could be almost anything. In our solutions, and we'll show you how these work in a little bit, we keep it simpler than that and yet still give them the opportunity to learn. Third thing is that we don't use the student interactions to train any AI models. Also, we turn on any safety features that are available in those models to make sure that the models themselves are enforcing safety. And then lastly, we've built a knowledge base that we use as the basis for answering the questions. And so as opposed to trying to draw from the entire internet, we have our solutions focus on a set of knowledge about Sphero robots and programming, and that helps to keep the answers safe and on target. Since we can check off safety as our #1 priority, it lets us go and look at some of our high-level goals. So first of all, we want to help students recognize AI as they're experiencing it in the world around them. I think if you look at your typical products, maybe your phone, for example, you will see, AI embedded in many things. And by our implementation of AI within our products, we let the students experience it in a safe way there and get a chance to understand, here's a place where AI is doing something for you. And that leads us to the second one, which is, how is it doing that? And a lot of the times when you use AI, it can be a little mysterious about how it works. And we find that both the successes and the failures of AI are worth understanding. As a person who leads a software team that develops software using AI-enabled tools, I get reports from my folks pretty regularly about how an AI might fail for them in the context of their work. And so correspondingly, as we show students the capabilities of AI, they can see what kind of data goes in and then what kind of answer the AI gives out. And typically that's going to be a really good answer, but in some cases it's going to fall short. And this lets the student understand a little bit better about how AI works. Lastly, we would like the students to have an ethical foundation here. It can be a little bit tricky to fall to the lure of AI solving your entire problem. So we don't present that kind of situation. There's never a button you can hit to totally create the program you need or to get your final answer. We give students tools that let them progress along and yet still have to go through the learning as they work on their problems. So the image on the right, I can, credit to Gemini for creating for me. Just to recap the way we think about the features, we want them to be safe first and foremost. We want them to be simple, so you don't need special knowledge or capability to use them, and nor do the students. And then we want them to provide something of value, and you'll see how we do that as I get to the end of my slides on the next slide, and Micah can take over. So before Micah gets here, just a quick plug for this document. I highly encourage you to bookmark this URL. This is our Sphero Educator Guide. And here is a place where we keep updates on all of the things that we're doing. And since the AI space and our ability to deliver features and content is all moving quite quickly, this is the one-stop shop for you to understand, here's what Sphero currently has available. That includes our goals and a quick overview that is a little deeper than what I've been able to give in these slides. An overview of the capabilities, the hardware, the software, the content, the lessons. And this is really a quickly evolving space. And lastly, this document has a reference section that covers guidance and frameworks from others. So you can go and understand how what we're delivering meets goals from other kinds of reference frameworks. And I highly encourage it. It's a quick read. It's a great handout in case you're looking to explain what we do to someone else in your organization. And with that, I have delayed long enough from letting you see the cool things of the AI assistant. Micah, all yours.
Thank you, Brian. Okay, so currently we have in our live releases 4 features. Before I detail exactly how these 4 features work, I want to quickly provide a little bit of information on the underlying technology. So our AI assistant uses a foundation model that has broad logic and reasoning capabilities, and then we augment that with a knowledge base specifically around our products and a lot of the intricacies of our coding environment. That way, we can ensure it knows all of the common things about JavaScript and Python and what blue means and what tree means. And then it can take that large base of information and use our specific knowledge to come up with really accurate and reliable answers. So our goal primarily is helping users understand how their code works with their hardware and assist in common programming problems. So that's kind of our phase 1 of AI integration. And as I mentioned, we have 4 features. The first one is explain my program, then code review, then block help, and then basically an AI implementation in our lesson steps. The right image there is an example of our AI panel in action when you're in a program. Next slide, please.
Yeah.
Okay, so the first question we had when we were building out our AI assistant is, well, does it accurately know what's happening with a program and our robot? And so the first logical step was to ask it to explain how a program works, and in particular with a specific robot. So when we engage with this feature, we are sending the code from the program, also what type of program it is, whether it's a block program, a JavaScript, or a Python program. And we also send information about the specific connected robot. So it can use all that information to provide an answer back. So in this example here, I have a program that just rolls my robot in a square, same speed, same amount of time for each roll block. And so the AI over here can intuit that this is a square path program. The goal of the program is to drive in a square, and it provides some information on basically the steps in the code, how it works, what various parameters mean in those blocks. And there's some fun little tidbits to note. For example, in its analysis, it mentions that it's rolling at full speed, meaning the AI knows that 255 speed is maximum speed. And sometimes it'll say things if you have like 100 speed, it's going medium speed or slow speed if it's lower. So it can kind of make sense of these types of things and present them in a way that'll make sense for users. We have 3 different explanation types: basic, advanced, and technical. Technical will always bring up the underlying JavaScript code even behind the specific blocks. So it's a really good way to understand fundamentally what's going on behind the blocks.
What I think's neat here is, Micah, is the explain my program feature is bringing out what I think is one of the most common questions: is which way is which with a round robot, right? So there's
Mhm.
it's 0 degrees is forward, 90 degrees is to the right. It's pretty powerful stuff.
Yeah, it does
That
a pretty good job of explaining those types of concepts.
is it intuiting it from like its general large language model database there, or is that our knowledge base on top of it?
So some things are pulled from the foundation model. For example, I did not have to teach our model what a square is, and it intuits the fact that 4 roll blocks with equal uh, speeds and time parameters, it determines that that's a square. So I didn't need to teach it things like that. However, I do need to add in information for things like what do our directions mean? It doesn't know that 90 degrees means right for our robot and until I go in and add that to our knowledge base. So it's a mixture of both.
Cool.
Okay, so that's a really like sensible place for us to start. We build an AI assistant. We want it to be able to assess programs and understand and report back accurately what they're doing. In this case, though, the next step is can it point out common issues, syntax errors, or limitations of specific hardware, or just kind of ways to optimize the code? So, for example, in this program, I have a drive block and then a roll block. The drive block pulls up on the screen of your device user interface to drive the robot manually. The way our code engine works is if you pull that panel up, and then if you do an automated roll command for your robot, it will disable that panel immediately so you never see it. So if you did a drive block and then a roll block, you would never see the drive interface. And as a user, you might be confused. So this is a type of behavior that the AI assistant can track down in your code. So if you do a drive with a roll block and there's no delay, it'll let you know. And you can see that in the right. It says, hey, this is an issue that's been identified. Generally, it'll provide solutions to get around the issue as well later on as you scroll through the answer.
I mean, I think this is a great troubleshooting tool because those we get those questions all the time in the classroom, like, why did my program not do what I thought it was going to do? And sometimes, well, most of the time, it's some kind of user error where they're not using our blocks in the exact way that they're designed to be blocks or that they're designed to be used. Particularly leaving out those delay blocks can cause some issues. We have a question here from a participant. What AI models is being used on the back end to develop the knowledge?
Yeah, so our foundation model is Anthropic's Claude Sonnet. It is quite good at balancing speed and then also efficiency, especially with coding tasks. That's something that we wanted to make sure the model would be good at is understanding code and interpreting what it does in a pretty efficient manner. So that's what we're using right now. We're always exploring different foundation models. It's worth noting that our instruction set heavily encourages the model to stay on target. So we, of course, build all of our prompts, but they will not deviate from talking about Sphero concepts, which means it heavily relies on that knowledge base. But yeah, it's an anthropic model.
Great. Yeah, and another question that's popping up too is how will this impact the Sphero Global Challenge submissions? Then this kind of goes back to our principles around AI and education. We're never using AI to give students the answers. So I would encourage teams, Sphero Global Challenge teams, if you have them, to use some of these AI features to troubleshoot their code or to explain blocks, as Mike is going to talk about very next and on the next slide.
Yeah, so we have a bunch of blocks in the canvas. Some of them can be a little confusing and overwhelming and less common. And so, well, looking at ways to potentially provide more information to users about how these blocks work, we decided to just pass along our block type and the connected robot type in our block help pop-up to our agent. And again, our agent has this huge knowledge base that covers all of our blocks and functions and see what would happen. And we got some interesting results. So for example, in this example here, I show the results when I'm connected to a Bolt Plus and when I'm connected to a Bolt for the main LED block. Now the main LED block will light up the LEDs, but on Bolt Plus, we have 5 LEDs around a central display. And on Bolt, we have a front and a back and then a matrix. And the way that the main LED block works for the matrix is it lights up lights up the matrix on the Bolt, whereas on Bolt Plus, it'll do the ring of LEDs around. So the cool thing here is that the AI knows about the hardware capacity of our robots, and it can provide a contextual answer based on the robot the student is using and tailor that block help specifically to the hardware. Oftentimes, it will provide little ideas as well to show how the block will work. Sometimes it'll suggest try this or try that. So this is a great way to provide a lot more depth of information as opposed to just a short little description in the app.
Cool. And before we move on to your next slide, Micah, I just want to go over to the Sphero Edu web app, just to show that this AI assistant is in all of our native apps, if on an iPad or an Android device, but it's also in the web app. It's up in the upper right-hand corner, just that button where it says AI. So you can see I have the program over here, and if I click on it, you're going to see the explain my program that's already been run for this program up and loaded over here.
And a fun little thing is if you change your code, this panel knows the code change and it'll let you know that if you want the updated or you want the answer to be accurate, yeah, you'll want to press that button again to get a new response.
And AI does take time. So when I hit that button, one of the reasons we didn't do this live is it could take up to 30 seconds, which is probably a good thing for students too, right? That they have to be a little invested to press the button and then wait for a response.
That was a pretty quick response there.
That was not 30 seconds, was it?
Nope.
All right, next one. Pop back.
Yeah, so the last of our current features is an integration into lesson steps. And so we've given our content team the ability to create specific prompts for any step that they would like in a lesson. This is completely optional per their needs. We do send the program if they want to send the program. So there are lots of great use cases. For example, in one of our zookeeping lessons, which just released recently, one of the steps in that first image has a button that provides a little hint. And we can track the session ID. And so if you've pressed it numerous times, it can give different hints. So this is a great way to pull in AI to kind of help learners kind of figure out what to do in creative ways. And then in step 3, when you hit check, it sends the user's program and compares it in the prompt to the expected code. And then it can tell you if you're on track where you need to be or not. So these are not like forcefully implemented in every lesson or every step. These are optional features for our content team to use selectively as they deem fit for specific learning objectives. But it is a cool example of what you can do here, especially the ability to kind of check your code and assess if there's anything wrong or give the students clues, both fun uses.
Yeah, what's interesting here is back to Brian's comment that we don't let kids type into an open text field, prompt AI on their own. In this situation, the content team, myself and some other colleagues, we're typing these prompts back there. And it's actually impressive how long some of these prompts are. So it might say something like, the first time this button's pressed, give them a hint related to X, Y, and Z. The second time it's pressed, give them a hint related to something else. But so this is a way that we can have students interact with AI without typing into those open text fields. Okay, and now we're gonna, Micah, you're still on talking about some new features we're thinking about.
Yeah, so the features I just showed you, those are out, and they were our first step of really, testing our implementation and kind of finessing our knowledge base. But we want to try to figure out ways to make some of the fundamentals of AI, part of our lesson material, and then also find interesting ways to actually make it part of programming with potentially with interesting blocks and whatnot. One of the areas that we really think is an interesting topic to cover is machine learning, and it's a fundamental part of AI. It's used in the real world for all sorts of problems, text to speech, autonomous vehicle navigation. I mean, they use ML models to track down diseases and solve all sorts of problems in the real world. We use the output of machine learning models every day on our phones and computers and so on and so forth. So we think it would be really interesting to potentially teach a supervised machine learning process with sensor data. Our robots have a ton of sensor data from the IMU, other sensors like ambient light sensor, and then of course the motor encoder data from the motors. You know, our robots move around and we can get a sense of where they are in a space. So next slide. I don't have anything to show. I have no concrete promises yet, but we are working on initial steps to build a system where you can collect sensor data from your robots. You can train it against a machine learning algorithm, validate that it works, and then use the output of that model in your programs in interesting ways. So this is an area, one, we're interested if this would provide value in a classroom setting. And then also, we're just interested to see what kind of things a machine learning algorithm could unlock in terms of creativity in programs. So this is an area we are doing some prototypes and exploring right now.
Great. We're entering the last section here, and this is where we're going to talk about the Hour of AI and Sphero's activities in the Hour of AI. So I believe many of you are familiar with the Hour of Code, have probably implemented it for many years in your classroom. Well, the Hour of Code is now officially the Hour of AI. So the organizers recognize that we all live, work, learn in a world that is increasingly influenced by AI, where it's all around us. But there are a lack of resources for learning about AI, things like an understanding how AI works, what AI is versus what AI isn't, and how to use it ethically and responsibly. So the Hour of AI has really focused on this concept of AI literacy, which basically means developing the knowledge, skills, and attitudes to be able to thrive alongside AI. This will take place similar to Hour of Code starting the week of December 8th, which is the CSEdWeek week. What's a couple things that are different about it is it's called the Hour of AI, but they're really talking about it as the Hour of AI and beyond. They want that to be the start of a learning journey that continues through the rest of the school year and beyond. And the second thing that's a little different, I think, is that instead of targeting just students, they're targeting everyone. They're targeting students, teachers, families, because we all have the imperative to develop AI literacy. They have pretty large goals to empower 25 million students, teachers, and families. So that's a lot. How are they going to do this? Well, the Hour of AI, Hour of Code has a lot of partners out there, one of which is Sphero, and they asked us to submit activities to be assessed and then put into their Hour of AI catalog. So we submitted 5 Sphero activities, and the good news is all 5 were accepted into their catalog. These cover a range of products. So we have lessons for Indi, lessons for Bolt Plus, and a lesson for Rover. This means they cover a variety of grade bands, everything from K2 to upper elementary to middle school, and even high school, I think is appropriate. And they also cover a range of those AI principles that Brian had talked about at the beginning. For example, we have lessons that will focus on just recognizing AI in the world around us, and then also lessons that help students understand how AI works, particularly the connection between data and computers' ability to make predictions. And then last but not least, we have lessons that help students learn alongside AI. If you go to the CS for All website, and then if you filter their catalog by robotics, that's the fastest way to find the Sphero activities. But I encourage you to also spend time in their general catalog because there's a lot of great activities from others out there as well. And I personally have been having a lot of fun exploring them. Want to take a deeper dive into a couple of these activities. We're going to start with an autonomous Indi lesson. So Indi is our robot for our youngest students. And this one is really focused on helping students recognize AI in the world around them. AI is much more than being about large language models. One very visible area of AI in our world is with autonomous vehicles and the increasing prevalence of those in our communities. So this lesson asks students to connect their Indy to the EDU Junior app and then set up a course. And then the first thing they do is they drive, which I'm not sure if it's not something I do frequently with Indy, but you can do it. So they drive Indy manually through this course. And then they program Indy to move autonomously through that course with the color tiles. So right away, they have an example of manually controlled vehicle and an autonomous vehicle, and they can compare and contrast those two situations. Then the lesson focuses in on this concept of training. And remember, here we're talking about like kindergarten students, right? So what do they need to know about training? Well, training is really just teaching a computer program to make decisions. So in this case, Indy is pre-trained to recognize colors and then respond to those colors. But you can mix up those instructions in the EDU Junior app. So this lesson challenges students to train the Indy on their own and to give it new instructions to respond to those colors to make it work for their situation. Switching gears a little bit, we're going to jump into a lesson that is focused on one of the features that Micah just introduced about our AI assistant. So we have these features. We want students to use them. We want to introduce them to students, but we also want students to think a little bit about them. Like we were asked, hey, what model is this using? These are all things that we want students to be thinking about as well. So this lesson uses Bolt Plus, and there's a program on the screen. Students are asked to look at the program, to look at the blocks, to run the program. And what happens when you run the program, I think you can see it, is if I shake Bolt Plus, it'll show a fish icon. And then it'll go back to the penguin icon when it's not being shaken. And students are asked to make use their own reasoning skills and their own powers of observations to think about what this program is and how it works. And then in step 2, they go over to the Explain My Program feature in the AI Assistant, and they hit that button, and then they read the computer's impression of what the program is and how it works. And they compare and contrast those two sources of information, right? And sometimes they'll find that the AI assistant is helping them understand what's going on in the program. And in other situations, they'll find places where the AI assistant might have made a mistake. For example, it might call things like the delay block a wait block. I've seen things like that. The AI assistant is not perfect, so it's kind of a two-way street. And so through this activity, they go through a process of kind of learning to program alongside the AI assistant. Okay, the next lesson I want to talk about is one that is much more focused on how AI works and this connection between data and a computer's ability to make predictions. This is kind of a precursor to some of those things that Micah was talking about us hoping to develop. But already, as Micah mentioned, these robots are stuffed with sensors. So this one has an accelerometer that is constantly collecting and reporting data about the forces acting upon this robot. One of these is an accelerometer that's detecting information about where the robot's moving. So this lesson is kind of formulated around this idea of a softball or a baseball pitcher. And kids are not going to throw Bolt Plus. We say that right up front in the lesson, but they are going to model some of those pitches. So the program starts and it says, hey, train me what a fastball is. And so students hold Bolt Plus firmly in their hand and they make a really fast pitch. And now the robot has a piece of data that it's associating with the concept of a fastball. Then the robot says, show me what a changeup is. And the student might make a much slower pitch with a changeup to give it some concept of what a changeup is. On every subsequent pitch, the robot will then try to predict what type of pitch was thrown. So it's not actual machine learning, but it is making a connection between data and predictions. And the learning outcome for this lesson is that On step one, they're going to give the robot one trial for each type of pitch. And then they're going to gradually increase the numbers of trials so that they develop this idea that, hey, the greater quantity of data that's used to formulate that model, the better quality of the output of that prediction. So you can see students at the bottom here are making a line plot of some of those predictions. So those are 3 of the 5 lessons that were accepted into the Hour of AI catalog, but they're only part of the lessons that we have. We're gradually growing in Sphero Central in our lesson libraries. You can see that we have 5 lessons here for Indi. Remember, we're talking about very basic foundational understandings for Indis. So my favorite one here is the sensors versus eyes lesson. We sense our surroundings with our senses, our eyes, our ears, etc. Computers perceive their surroundings with sensors, right? And they're making that connection. Very basic understanding for students. We've got 6 to 7 lessons for Bolt and Bolt Plus. And we have 3 lessons for Rover plus that collection of 10 lessons that use that in-step AI support to give support and feedback to students. We are always looking for feedback on these lessons. So if you try any, please send us an email or contact us and tell us how it went. If you have ideas for other lessons, please send them our way. And we are going to have one last full poll before we move to Q&A. So what additional resources could Sphero provide to help develop AI literacy? In the first question, you have some pre-selected choices that you can choose from. Number 2, you have a little open text field where you can give us some other ideas. And I think we should just let that poll ride a little bit, keep it open for you all, and move on to the Q&A to see if we can answer some questions.
Todd, I saw one question about the AI assistant ever costing money or having limits. So I'm happy to dive in on that one to start us out.
Yeah, please do.
So I can't see us ever charging for this. The AI assistant is, meant to be super compelling, but we built it to be as efficient as possible. So there's a bunch of shared infrastructure here that gives us the capability to do all of these features from, a single set of costs for running this knowledge base. And we do monitor the costs, but right now we think that the value of this for you is well worth us running it. If we ever come up with a feature that is so demanding that, it is infeasible to offer as something free, we would definitely let you know ahead of time about that.
Okay, great. We're getting some questions here about using our lessons or some of these features with legacy robots. So Micah, can you speak to, let's say you have let's say you have a Spark Plus robot. Will the AI assistant features work for legacy robots?
Yeah, all of our robots that you can connect to will work with the AI feature. The AI feature is primarily assessing the specific code. And in our knowledge base has information about compatibility for all robots. The only thing worth noting is that not every version of every Sphero Edu app supports all of the older robots. For example, our web app doesn't support Spark Plus or any model older. But for example, if you're using the iOS app or the Android app, you can certainly use the AI feature. I will say most of our testing and tuning of our knowledge base has been focused on our most used current robots, but it will work with the other ones as well.
And as in terms of the lessons, we may have to the lessons are designed for the robot they're written for, but that doesn't mean that you, particularly with Bolt Plus and Bolt, like the lesson I showed, Bolt Plus doesn't have or Bolt doesn't have an animation display, but you could easily tweak that program to work for Bolt. Um,
Yep.
Seeing some questions. Actually, this one's easy to answer. Why is that fifth lesson not showing up? I have an email out to code.org and they're to tweak that. I think they just missed the robotics filter on that pitch lesson. You can find it if you type pitch, and hopefully that'll be figured out by shortly. Next question. Caitlin asked, do you anticipate adding more AI lessons in the next months or year? Definitely in the next year. Our library is constantly growing. It's one thing we're always doing. The content team is always looking at adding to our lessons to grow those collections. So yes, certainly there will be new lessons coming.
Todd, we do have one in the Q&A about availability in the apps, and I'm happy to answer that.
Yeah, please.
Yeah, so the question is, will the AI be added to the Sphero app? Currently, I'm not finding it. So the AI feature is, there are a couple things to note. All of the features are in the 8.2.0 release, which rolled out to devices last week. If your apps automatically or do not automatically update, then you won't have it yet. And this gets a little it can get a little messy with schools depending on how they deploy software. There's also a scenario where if your device is old enough, or using an old enough operating system, we might not be able to get you that new version of the app. The only other last kind of piece of information here is that we've released this across the board with the exception of the Windows app. That is coming next week. But iOS, Android, our web version of Sphero EDU, the Mac app, those all have the latest features. And if you're not seeing it, I am happy to help troubleshoot potentially via some other channel or through our support team.
Okay. A question continuing in that same vein, Micah. In the browser, does the AI feature get blocked by school filters? Have you had any problems with the AI assistant in the browser?
So we haven't had an issue yet. We all of the traffic goes through our Sphero APIs, and as a result, uh, those are generally safe and not blocked. But I mean, the world of IT is always changing, so we will monitor and keep an eye out, but we have not heard any reports of any issues with it being blocked. And that's primarily because we are using our specific APIs, and those are generally unblocked, so schools can use the web app. But if anybody here runs into an issue, let me know. We'll fix it.
Great. And then we got a couple of questions about which lessons, which robots are good for beginners. Um, I think that if you are up and running with a robot, for example, you know how Bolt Plus connects to the app, you know you can create your first block canvas. Similarly with Indy, you know you've been able to turn it on, you've been able to program a simple path with the color tiles. These lessons should all be accessible for beginners. We're not asking students to do to create their own complex block programs before they can get started. So my recommendation would be to try any of them and see how it goes, particularly the ones in the Hour of AI catalog. And question, I know we will be sending out a recording of this shortly. And you can also reach out if you would like a version of this slide deck, for sure, reach out to me and I can make a copy without some notes and things like that. I don't know. Micah, Brian, are you seeing any questions we haven't answered? Oh, here's one last one maybe for you, Micah. Does the AI model learn and improve the more users interact with it? And
Yeah.
also a privacy connection of this one, are interactions linked to a user's account?
I can take the first one if you'd like, Brian, and then you can do the second one.
Sure.
Yeah, so right now, it gets smarter by us providing it more information in the knowledge base. I am currently looking into ways wherein we can mark incorrect answers as being a problem, and that can go and reinforce what not to do or what to do next time. There's a lot of like depth to building out these systems. But right now, it really relies on our knowledge base of information and the accuracy of that information. But yeah, I'm still looking into ways for it to kind of learn a bit more over time.
And just to tie on there and then answer the next question, if you ever see something in the use of these features where you say that, well, that's not what I expected, or that seems like it's not being helpful like I expected it to, we definitely love the feedback. You can send it to our support team, you can email either of us directly, and we're happy to get that feedback. As Mike has said, the power that we have here is that we can train the knowledge base to be better and better, but we are carefully cultivating that data that we put in there so that it's not sort of willy-nilly updates to what drives this system. With respect to privacy, we never send personally identifiable data. You don't need to be logged into the Sphero Edu apps to use these features. You don't have to have an account. This is all based on you being in the programming UI or you working on a lesson. And then those calls over to ask the AI questions never pass anything about the user.
All right. Um, and Chris, thank you. Yes, Deborah, we will be sending out preview certificates and just give us a couple days. And I think that is all we have time for. Thank you so much for joining today and keep checking back to see what we do next in terms of our AI assistant and our lessons and resources. Appreciate you stopping by.